All right. And our final speaker, last but not least, Professor Williams from McAllister is going to tell us about curricular things. Anna.
Great. Thank you to all my colleagues for introducing everything so well. I just get to highlight the projects that we've been doing in the classroom and basically how we've been trying to use this as a teaching tool in the classes that we already have going on at our various institutions. So from my perspective at McAllister, this is a huge upgrade. This is our old 16-inch telescope on the roof of our science building, which is located where that point of that arrow, the tip of the arrow there. And you can see that's basically in the center of campus at McAllister. And just south of that observatory are, our fantastic sports fields, which like to have really, really bright lights on all the time. So you can see that, trying to use this telescope on our campus isn't, the easiest to get high quality data. And if we zoom out from where McAllister, from our on-campus map of McAllister, we're smack dab between the center of Minneapolis and downtown St. Paul. So we also have this large city area to deal with in terms of light pollution and poor seeing conditions at low elevation in the Midwest. So this isn't something that's unique to us at McAllister, right? All of our consortium members are also struggling with similar types of observing challenges at their institutions. So to have this telescope down in Weiner has offered us a huge opportunity in being able to get much higher quality data to have students do real science at all various levels of the curriculum. And we've even been fortunate enough to, take a spring break trip down to the observatory with our observational astronomy class, so they can actually get hands-on time with the telescope as well. Oops. So here, I'd just like to highlight the various work that has been done in the classroom and the number of students that have been impacted since we began officially January 1st, 2023. So at Augustana, by joining this consortium, they were able to push for a new astronomy minor at their institution. So with the addition of this instrument into their classroom, they'll be able to do much more in-depth science and provide their students with more rigorous curriculum to accomplish a minor in astronomy. We've heard about the longstanding tradition of the RLMT and robotic telescopes at Iowa, but since the Gemini telescope has become the RLMT telescope as part of the macro consortium, over 200 students in an introductory class have been using this telescope along with an advanced observational class. In Knox College, who just recently joined, this past year, our consortium, they're already implementing this into their observational astronomy class. And then at McAllister, we've figured out how to use it every semester so far. So it started out with the special topics class last spring, just to get to know the telescope. We had a first year course in the fall on the solar system that students got to interact with data. And then we really pushed the telescope through its paces this spring with our observational astronomy class. So as I mentioned before, we're able to hit all levels of the curriculum with this telescope. So as I mentioned, this first year course in the fall, students were able to extract data, these observations of an asteroid in order to create asteroid light curves. So first year students were using AstroImageJ, getting the photometry. I had prepared a Python notebook so that they could read stuff in, and then, they didn't have to have too much coding experience, but then they could start to make predictions about what does this asteroid look like based off of the asteroid curve. We could look it up online and they could check whether or not their hypothesis was correct based on the data. We also were able to get reflected spectra of gas giants, which is shown in the lower right corner here. And so we've got a spectrum of a sun-like star, since reflectance spectra of planets will be reflecting sunlight. And then we've got a spectrum from Uranus in orange and Neptune in blue. And something you might notice is that all of those absorption features don't really line up, which might seem a little bit weird. This is when we were still getting to know our low prism spectrometer and also learning how to reposition our telescope. So we had the fun exercise of having the students figure out, is this a physical effect? Are these planets actually moving at these speeds relative to each other? Or is this an instrumentation effect or calibration issue? So we were able to ask those types of questions and put the students, students doing different types of quantitative analysis with this data. And then at Iowa, I'm highlighting here some of the gorgeous tricolor images that they were able to do in their introductory astronomy class, in addition to selecting galaxies that they could get images of and then measure the diameters of as well. So a variety of different types of science that can be done for your introductory students with this telescope. Oh, I would also like to highlight all of these courses and all of these projects also involved writing activities as well. At McAllister, I had the students writing memos. I tried something different than typical lab reports. So I had them address the college president on what we can do with this telescope so they could experiment with different types of writing that they might see if they don't continue on in the academic setting. And then here, we've already heard a little bit about all of these different science projects, but at the upper level courses or in the upper level courses for the majors, we really have been trying to give the students an opportunity to have a real experience of being an astronomer. As John has highlighted, or as several other people have mentioned, with this telescope, we want students to build a project that they are interested in from the ground up. So they get to pick what type of source, they get to figure out whether or not it's observable with our telescope. We've got a variety of tools to help them figure out their observing times and to actually plan their observations. And then they can go to bed while their data is collected. And I know probably a lot of people here might struggle with their undergraduate students being very involved with a variety of things on campus, which is amazing. And I'm always in awe of all the various things that my students are doing. But at least they can get some sleep while also getting to do some astronomy research. So at Knox College, Natalie had students doing looking at an open cluster where they can make a color magnitude diagram, which is highlighted up in the top right there. So that was more of a lab type activity where everyone got to do the same type of science. And then here I've just listed a variety of the different student projects that students chose to do and the types of objects that students chose to observe with our telescope. And most of these things are highlighted in our poster session. So we had students choose to do a variety of variable and transient observations, the cataclysmic variables, eclipsing binaries, exoplanets, supernova, surface brightness profiles, as was highlighted previously with the star clusters, as well as doing surface brightness profiles of galaxies as an independent study at Knox, which is shown in the lower right. And then we also introduced the spectroscopy at the end of the semester in the McAllister course, where students were able to do spectral identification of stars with our new spectrographs and our prisms. So I just think that I'd like to highlight the major goal, and as I said previously, right, is to give our students the chance to see what it's like to be an astronomer, right? They're majoring in astronomy, they're minoring in astronomy, but what does it look like to follow that as a career, right? Can we give them the experience of, planning a project, figuring out time management to get things done, right, in order to get to some results that they can share with their community within their classrooms. So we're really excited about how this has been going so far as a first run in this past 18 months, and we're very much looking forward to the future. So I mentioned this before, but this is sort of the thing that you kind of think about in terms of your introductory astronomy classes, right? The quantitative reasoning that people are taking this class, even if they're not planning to major in the STEM fields, and to get some experience with their communication skills and working on that. So those are definitely things that have been highlighted and are, very obviously a part of using the RLMT in our classroom with the types of analysis that students are performing, in addition to the reports, and now here, the posters that they're presenting. But then in addition to that, right, the project management, the project ownership, to really feel like they can be a scientist and see what it's like to be a scientist. I love seeing the collaboration that happens between the students, and I'm looking forward to the collaborations that we're going to be having across the various institutions. As has already been highlighted, all of the data that we take is available for everyone. And so we've been sharing different types of activities that we're doing in the classroom, and that's something that I'm looking forward to continuing to grow with folks at Augustana and Co. and Knox and Iowa, to have these useful notebooks and different analysis tools so that we can get students doing astronomy research at every level. And then I also think that, you know, any type of research that you do in any field is really an opportunity to learn how to learn, right? That's really what we're trying to teach, I feel like, at undergraduate institutions or just, you know, in any classroom, helping students learn how they can learn so that, you know, it's not just what you do in the classroom, but it's the types of research projects and the different activities that you do outside of that as well that can broaden your perspective and help you along in your career. So with that, I will leave a bunch of fun pictures of students working with our various parts of our telescope, experimenting with our IFU, and you know, fixing bits and pieces and cleaning bits and pieces of the telescope when they got to come visit. So yeah.